Hey guys, how are you? So I'm making this video for Zachariah of Illinois, if I'm not mistaken, Illinois. So he was asking me about my MIG welder conversion to accept flux core wires. So I converted a MIG welder to a flux core. So I think they are different from what I have watched and read before. So flux core welder and MIG welder, although they look similar in machine type, they are practically different in different cases. So he was asking me how I did it, what materials, what wires I use. Sorry, I got candy in my mouth. Yeah, so basically that's what he's asking me, and what are the terminals that were involved in doing it and stuff like that. Okay, before we start, I would like to first say that I am not sponsored by any company or whatever tools you may see here. I'm not a sponsor of them, as make it short. And I'm doing this video just to clarify. I think he watched my video in my YouTube channel. So anyhow, so yeah. So background of the unit. This is the welder itself. Let me give you a big. Yeah. So it's a Clark MIG welder. That's the original setup of the machine. So I bought it for 50 Canadian dollars from someone, and this was not working when I bought it. It was working before. I was informed by the guy that I bought it from. It was working before, it's working nice and stuff like that, until one day it doesn't want to work anymore. So anyhow, yeah. So originally this machine is for MIG welding. So when you say MIG welding, we're using gas as a shielding for your welding. Like gas comes through here. It's an argon carbon dioxide mix, or carbon dioxide. I think carbon dioxide, pure carbon dioxide will work too, but I'm not sure. I know pure argon will work too. So yeah, so that's the original design for this particular machine. So converting this to accept a flux core wire, which is practically, it looks the same process, the same stuff, but the material that's inside the wire itself, the wire has a flux already built in or embedded inside the actual wire. So the wire is, just imagine the wire is hollow and it has a chemical inside to to serve as your flux. So you need flux, or you need the flux, or you need the gas shielding for welding, to make your welds a little bit more penetrating to the metal that you are welding, if that makes sense. So it kind of prevent oxygen from entering or contaminating your molten metal together. That's being welded together or moltenly joined together because of heat. You know stuff, melting stuff. Yeah. So you're just melting two materials together. If you introduce oxygen to that, there would be consequences that your joint would have bubbles and stuff like that inside, would be porous or something, and it will easily break or something like that, or all of the above or something like that. So now, when we talk about this, what I did was, the basic, of course, would be just showing you. So MIG welders or flux core welders or the other style of welders, as long as you see it has a polarity, which is like right now, you'll see this. It's not just there for design. It says it's negative. So your clamp here, well, I'll just call this a ground clamp. You just whatever, call it whatever you like, but it's the piece, it's the clamp that you grab onto your material that you're going to weld, and this is your handle that has the welding wire coming out of it right there. So when you have polarities like this, so this is your negative and this will be your positive. That's how it goes. So now for MIG welder, the setup is like that: positive handle, negative ground clamp. But for a flux core, okay, the reason why is it's because if you put flux core on this machine, the flux core wire on this machine, it will weld. Yes, it will weld. But unfortunately, your weld will be splattery, or I don't know how you describe it. It's like puddles and puddles of molten round metal all around your weld. It's not like a clean weld. It has dirty kind of looking weld. So what we are going to do is, the basic design for a flux core welder would be, this one would be your positive and this one would be your negative. So it's just like inverting polarities. But now we are doing it inside a permanently or fixed MIG welder. It's a fixed MIG welder. It's not the ones that you buy, the new ones that you buy, you can just pull one and just flip it over. You can change immediately a particular machine that's intended for MIG to what do you call this, to a flux core, or even a TIG welding, TIG welder. So in which case, this isn't it. This is different. So now I'm going to try to make this video without even cutting it. So it's no editing, no cutting whatsoever. So what you will need for doing the conversion for this particular machine. So the materials I uh, I bought basically is just a 2-wire cable like this. Let me close up of that. So it's just a thin wire with 2 cables inside, a red and a black. So I bought this from the closest hardware store near our home, near our house. So that's all you need, plus a switch. So okay, so that's all that I did use on this particular machine. What the switch that I have here, this is for a lampshade. Yeah, I remember, this is for a lampshade. It has a what do you call this? A locking. It locks when you press it. It locks when you re-depress it. It turns off. But I removed that option, so it's just a momentary switch now. So you just press it and that's it. Press it, let go, it's on and off. So the only thing I bought is this one. This wire. Let me see. I can see a American wire gauge, yada yada yada. I'm not sure what this is. It's it 13. Or 20. 20. It says 20 American wire gauge. So I don't really think you can use a speaker wire for this. As long as it's two cables, it doesn't matter. So I did this on a whim because I had a project that's hanging, so I needed the welder. So I need this welder to be useful in such a short time that this is a rough how I did it, and I haven't done anything to it yet. I had finished the project that I'm using this for. There are about other projects that I did with this machine. I already have a flux core before. It's a Chinese flux core welder, but it's kind of, when you use it, when you're already welding, it kind of, the current, the strength that it's welding with kind of drops. You can feel it like it's like it's fading away. So how I use that to compensate was to like that. So on off like that. So with this one you can go a little bit longer. So, and it has a steady output. So I retained this one and sold the other, the Chinese flux core. So now, saying that, the only thing you only need to do is change polarities. Like I said, we are changing polarities on this thing. First of all, as you can see, this is your rectifier. Let me take you off the tripod so that I could show you more. Like I said, I didn't buy any what you call this, expensive stuff. I think I just bought this from it's not really expensive, this American wire gauge 20 wire. It's as long as there's two there. I'll tell you why later on why you need this. But yeah, if you can modify this better, I would then it's good for you. Okay, first of all, as you can clearly see, I just moved this large heavy gauge handle wire. This is your handle, this one, from here to there. As you can see the bite marks of the washer right there. Just moved it there. And the other side, you can see it right here. I moved it to the rear side, right there. Now, like I said, we're changing polarities. So first, you must know your polarity just by using your multimeter here. You use this multimeter to find out the polarities on your rectifier. Yeah, so this aluminum weird thing here is your rectifier. So you'll see diodes there. This one's diodes right there. From this particular design, you got 1, 2, 3, 4, 5, 6, 7, 8. 8 diodes there. If I'm not mistaken, it's a full bridge rectifier design. You can Google that, full bridge rectifier, how it works and stuff like that. So your rectifier is like converting your AC, which is your transformer here. This is what your transformer is producing. AC is also your input. This is your input, which is your house power. And this is where the wire that you plug onto your wall. So whatever you call that. So your transformer has a windings and stuff like that. There is a primary and a secondary winding. Usually the secondary winding would be your output. For this particular design, is your secondary winding is your output here. Output, yeah. You saw your output. So depending on the design, this one in particular is a step down transformer, which is converting your 120 volts household voltage to something smaller. The output would be somewhere around 40, 35 or something like that. Depends on the winding. So let's just say it's 30 because I get 30 volts from here. I'll show you later how I get the voltage from here. So AC 120 volts goes in and goes out as 30 volts AC. Still, it goes in your rectifier and it comes out this one and that one. This, yeah, that one, this one, this wire as your 30 volt plus positive 30 positive. It's polarized already. It's got positive 30 and a minus 30 right there. So it's polarized. It's got a positive and a negative now that we could see, just like your basic battery charger for your cars. That's big enough for you to see. So yeah, so now your AC from your secondary winding goes in this one, these two terminals right here, right there. So it goes in there and rectified and becomes DC output. So I'll show you what I'm talking about. Let me put you back into the tripod. Onto the tripod. I will raise you up a bit. Good. There. Right there. So you could see, what do you call this? You could see the two plates. It's clearly seen right there, the two plates. Right here, the two plates, this one. So now, you just switch your multimeter to voltage. DC, just to make sure it is DC written there, because you could press it to AC like that. There are different multimeters that is being sold out that has a separate dial for AC or DC and stuff like that, or voltage. In this particular meter, it is automatic. When you put it on voltage like that, it's going to read voltages up to a certain high voltage and a certain low voltage, and you could just flip it from AC to DC with just a push of a button right there. So do you see that? You don't see. How can I put you right there? Whoops. Something to put there so that you could see. Okay. I hope the light is not in the way. I hope you could see it from there. Okay, now I already plugged this welder to the outlet, and let's turn it on. Turns on. So on your tester, you have a red and a black probe. So basically, your black is your negative and your red is your positive. So right now, I'm just going to probe it in any position. Watch the can you see that? Let me try holding it like this. If you see this small dash on the side there, alright, there, you see a dash? That means I am reading negative 31.17 volts. Now, that means I'll just have to flip this 2 over and test the other way. So you see now that there is no negative on the front of that 31.5 or something, 3, 4. Okay. So that means this is already your polarity. You can see. So The inside plate, right here, the inside plate is your positive, and the outside plate, the outside heat sink, they're all both heat sinks. So let's just, this heat sink right here is insulated from this one. So this one is your positive and this one is your negative, the outer one, which is close to your cover and stuff like that. So now that you know your polarity and you know your target polarity for this thing, for these two stuff, you only need to flip the cables over. So right now, since this is already converted, I flip this over to this. The bottom one, which is your previously connected to your negative, now is connected to your positive. So now basically that's already what do you call this? The requirement for your TIG. I mean your flux core. Sorry, your flux core. That's already your requirement. But unfortunately, it is not just that you'll need to change. Okay. First of all, I'd like to show you what the inside of your handle, the inside of this thing. So I need to show you. I'm not going to anymore show you what's inside because it's already taped and I had a zip tie on that, but I have made a drawing for you. So just to give you something to think about. So I'll just flip this so that you won't get confused. Okay. So this is your gun. Forget about the ground clamp for now. This is your gun. So this is where your wire comes out. Stuff. So now your large wire, your large ampere wire, which is the one that I show you on top, which is connected before to positive. This is your positive. It's large. I don't know what gauge is that. Maybe 10 or something. As long as it's around 30 amp capacity, you look at it you look it up in Google. I think it's a 10 gauge. It's a 10 gauge to absorb or to carry 30 amps of current. So you can grab 8 if you want, as long as it's higher, it's good. But in this case, on this particular welding machine, this the one that we're talking about right now, I did not buy any large wires. No, I did not. So now, the design on inside of your gun is like this. So this is your high current wire. This is your flexible kind of thing. This one. This one. I don't know what you call that, but it's the one inside your gun and go through your what do you call this? This fat hollow whatever. So that one and a single wire of a single wire, approximately a 12 size 12 wire that's inside there, and your switch. This is not the switch that I attached to the handle. This is not it. This is the original design. So now, before, this is positive, so that means this is also a what do you call, this is the hard part of your gun, which is, this is brass. It's made of brass. This piping here is screwed onto this. This is attached to this portion right here, and your wire goes through there inside like that. So this is a brass portion. It's like the structure of your gun, so that this particular front facing pipe here, your nozzle, what do you call this, is not flopping around. So this is the like a hard place to a sturdy or a stable attachment, so that this won't wobble around. So that's, so positive, like I said, positive high ampere cable attached to your brass holder. So positive is being introduced, positive polarity, positive current, positive voltage is being introduced to all of that portion, metal portion right there. So your switch, when you depress your switch, your trigger, when you depress this trigger, this is the original trigger. Don't look at this one. This is the original trigger. You press that, like that. So you are introducing positive to this wire. Now, this positive wire goes to this one. This terminal right here. I zip tie them together like this because this was previously here. Forget about this terminal here. This one goes to that. So when positive is introduced here, this is your thermal switch. So when your rectifier overheats and this senses it, this will cut off power going through your wire feed. The other side, the other terminal right here, goes to your electronic wire feed system right there. So wire feed controller, switcher thingy. So when the rectifier overheats, which you can overheat them, you'll just cut it. I mean, you'll just turn off the continuity of your this portion right here. So even though you press the trigger, you won't get any wire coming out of your gun. So it's like a safety thing to prevent your rectifier from blowing up. So I remove that. Now, because the reason for that is when I kind of flip this over, this is your positive supposedly, which is connected here. Like I said, if you remember, this is your positive and this is your negative. So when I move this wire from negative to positive, on our drawing right here, I am introducing negative to this portion right here. So this now will be negative. Everything there is negative. So when I press the trigger, if this trigger is the one I'm using, if I press this, I am introducing negative to this wire, negative to this wire right here, and it goes to, like I said, goes to your electronic controller here. Nothing will happen because it has already a negative, fixed negative that is on the electronic controller here. So it has already that negative. So nothing will happen. So what I did was That's where this switch and this wire comes in. I put this thing here, a momentary switch, and the two wires are these ones. As you can see, one of the wires, which is your red, it doesn't matter really, whatever color of wire that you buy, it doesn't matter as long as one of that wires that you have is connected to your positive and the other one connects to your this one. So now if I press this switch, I am introducing positive through here, so my wire feed will work. So now you can weld. Press, wire comes out. Wanna see? I'm going to press. There, it's coming out. So I have control over your gun already. Okay. We're not finished yet. We're not finished. So, talking about that, I'm going to remove you from the tripod again. And I'm going to show you something else. Okay. So now basically you can weld. Basically you can. But there's a but there. So what I did here is just for me to be able to weld immediately, because I wanted my project to be finished as fast as I could. So like I said, I did this on a whim and I wanted it done as fast as I could. If you are looking at your welder light right here, you can see your transformer, and wait, there's another one right here. So it looks like a transformer, does look like that, but there are only two wires that are on it. This one and one on the inside, right? I don't know if you can see that one right there. See that one? Okay, so this is like an inductor, or let's just say a ballast or something. I don't know what you call that, but anywho, this is used for it creates voltage on itself though. So when you let's go. I'll talk to you about this later. So this is your contactor. You can call it contactor, you can call it relay, but it's contactor if you're talking to electricians and stuff like that. So this is a contactor. It's got a those holes are terminals right there. So this is this large tin right here that's fed through the those portions right there. You can see right there. So each bank, each hole, you can see 4 holes, right? 1, 2, 3, 4 holes. Each hole has a contact point on them inside. So each hole is independent on itself, but right now on this design, it's the contacts are being utilized by one single wire. If we call this tin as part of the wire. So on the other side, you can see that too on the other side right there. Let's push this over. See there. So this is your solenoid center. You can see it bob up and down. Let me show you closer. Oh, how do I click? Oh, there. So this portion right here, right there, goes up and down. Yeah, like that, like that, like that. So this one is controlling this, controlling the other half of the points that will slam on the contacts on the bottom. So 4 contacts on top, I mean 8 because they are a through kind of deal. So 4 plates on top like that. So when you put power to your control side of this contactor, it'll depress and contact both sides, making a continuity to your circuit and stuff like that. So this is your control side right here of your coil, of your solenoid for your contactor. Right here, the white one, the 2 white wires. So these are the control side. So when you press your trigger, in this case this one, there's another relay on your controller right there. So that one. So it provides a contact and provides power to your solenoid coils and engages your contactor. So we don't care about the control side right now. What I'm concerned about, so now this one, like I said, we flipped it over. I'm going to go back to that so you can see. We flipped it over. This is supposed to be positive. Now it's going to be negative. And that bottom one, if you look closely, this one, this tin here with the wire right there, this pigtail looking thingy, supposed to be negative. Now it becomes positive. So positive goes through there, goes to your contactor contacts. When it is depressed, it goes to that other side. It goes to that large wire over there, large transformer wire. Winds here, winds, and comes out to this one. And this one goes to your ground cable, ground clamp, right? So now there is a reason why this is connected to your negative before the original design. There's a reason for this, why it's connected to your negative. It's like I don't want to go into every detail, but now I have made this just to weld, but I want you to change it to the correct way. I mean, if you're going to convert this thing, this machine, do it correctly. So what I did here was a little bit rush, like I said. So now that you're going through this, I think it's better if you cut this in half. We need this inductor, this ballast or something like this, or something like that. We need this ballast to be connected to your negative, just like the original design. How this machine was designed before. So this is negative supposedly. It's absorbing, its negative is passing through here, so it kind of charges electricity in certain way, and when things collapses, yada yada yada, it makes a very large voltage spike that may be detrimental to the machine. So this one, since I'm not really using it, like I said, I'm going to reiterate it. I did this I wanted it to be fast as much as possible, so I wanted to weld as fast as possible, so I did not touch this anymore. But since now that you are going to do it on your machine, I would like to suggest you do it the right way. So now we will isolate this one. We need this to be on the negative side of your system. So it is connected via that. So it's crimped. That heavy gauge wire there is connected directly to your transformer wire, which is also fat, like that. So I will cut it here. I'll cut it, and I will try to introduce a terminal for it and crimp it again, and this one let it hang for a bit, put it somewhere here or so. Then now this one, where is that? Yeah, this one, since now it is negative connected right there, you remove it from here, remove it there, remove it, then put it on this side of your ballast. This one, you cut it here, right? You cut that, remove that, forget about that, cut that, and get a wire as large as this one, a large gauge wire. Like I said, it's probably around 10 gauge or an 8 gauge. Get that and attach it. Attach this wire to this side of your what do you call this, ballast side, and this one, and half, right, the other half, which is connected directly to your ground clamp, the other half you put another terminal there and you route a wire going to your positive. So now you don't need to touch this portion right here. You don't need to touch that. You just put it back here. Just put this here again to the original. You don't need to touch it. So now when you depress your trigger, same thing will happen. You don't need to change this wire. You still need it. You still need this. So when you still depress it, you'll still have positive going through to this wire. So now when you trigger that, negative now will flow to this wire, go through your contactor, go to your ballast, and goes out to this wire. So right now it's on the negative side right there. So you're using the ballast on the negative side, and you did not change anything except for the polarity of your this ballast thingy, how it's in the circuit. You just placed it in series with the negative side of the circuit. So I just cut this in half. Now the reason why I didn't do that is because I have to tinker with this. I need this particular machine to be easily modified if ever I would make use of it as a MIG, because the hoses are still there. There's the hose for the gas. It's tied up behind there, right there. So I can still convert this without changing anything. I just move this, move that, move this one to this one, and put this terminal back onto this side, and basically I got my MIG back again. So it's like that. But if you are going to go the mile and do it correctly, you can put terminals to this so that you can swap it anytime you like. And you're doing it the correct way. So yeah, just sever this, make a terminal and stuff, and route it the way I showed you. This one would go to your this wire, your gun, high current gun wire here. This side of this side of your ballast, and this side of your wire here would go directly to your positive right there. So now you, with that being said, you now need to buy these wires, this large gauge high current wires. You now have to buy them 2 feet or 3 feet. The more the merrier, so you could have space, you can move it around and stuff like that. So that's about it. You have, after that, you have converted your machine from your MIG setup to accept flux core wires and stuff, and you know how to put it back to where it was without disturbing anything, and it becomes a MIG again. So the only, and yeah, so that's it. So the next one I did, if you're looking at this right now, there's a fan there. So originally there is no fan there, but I added a fan just to cool the rectifier. It's better to have cooling and stuff like that. It's not going to hurt your machine and stuff like that. So this is a 12 volt fan. It's a 12 volt fan. It came from a computer, of course. It's a cooler for computers, and it has enough air volume to keep this rectifier a little cooler, because it doesn't have a fan per se, so it must be cool enough to not be the heat must not be enough to kind of burn this thing. So anyhow, keeping it cooler is not really that bad. So it's up to you if you add one fan. So I routed this fan. So it's a 12 volt fan. I used a small charger thingy here, right here. See, you can plug this onto your outlet, right? But I soldered it there, and I don't have what do you call this, a lot of I did not open this up anymore, so I just wired a extra wire there from wherever you can. That's why I don't throw them out. So I put power there. It's a 12 volt 1.5 amp output. It's a 12 volt 1.5 output. Strong enough for my small fan, and I wired that cable here. These are the cable for, is the wires for the what do you call this, the transformer itself, the AC. So one is directly connected to, I spliced it here, which is your neutral ground, the white one, and that's your neutral. And the other side is the switched side. See, it's connected to the contactor. because your contactor is AC, it's not DC, it's AC 120 volts. It's electrical contactor, that's why it's AC. And it's 120 volts, maybe switchable to 250 depending on the coil design. Sometimes you can put 240 on it. It depends. Depends on manufacturer and stuff like that. So I just looked for the side of the coil that has connection with our switch. When you power this up, there must be one side of the coil that will have power. To do that, you need to have your multimeter ready and switch to AC. So just switch it on and you'll find this one to be to be having a power, and the other side would be a trigger, so that when you press this one, tit 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 like that, your relay will contact and power will be fed to the other side of your coil, your contactor control side, and that engages and means that other side has power and it powers my fan. So that's about how the cookie crumbles. So with that modification, the right way to do it, I don't think you're going to spend a lot of let's just say you won't burn a hole in your pocket. It's just whatever you have in your shop there, in your garage and whatever and whatnot, you might be able to do this just like that. So just remember, when you're severing this one, even though it's a you think it's just a solid wire, just like this shiny portion right here is insulation. You need to scratch it like this one so that you'll get contact. If you don't scratch it, if you don't remove this shiny smooth portion, there is no way for you to contact the wires. You won't be able to. That's why you need to get it really bare copper color wire, not the black one. You see that? And let me just move this fish insulation out. See, so there's a brownish shiny color there on a solid wire. The other side where it's crimped, it's kind of scraped and rough. It's shiny too, but it's silvery. So you need to do it the silvery way, that silvery looking thing. So you need to scratch it to that particular what word is that? To that just scrape it until you get that to get to the substrate or the metal itself, because like I said, the brownish color thingy is an insulation. It's just like these wires. The copper wires are inside and the outside is covered with plastic. That one is like varnish laminate, so it's different. So the reason maybe that this is not copper colored is because this is an aluminum wire. Maybe I'm wrong. If you remove this, if you cut this here, and this is very malleable, it's aluminum. Copper will kinda, with this large of a copper wire, it's kinda going to fight you just a bit. But if it's aluminum, it's just going to be as easy as moving it around. Not really that hard. So yeah, that's it. So I hope that that clarifies a little about what I did, and I hope you get your machine to what you wanted it to do. You said you wanted it for flux core. Yeah, that's how I did it. So if you have so there's another way also. If you have a aftermarket of this, or you have somebody that has, well, it's in Amazon, you can buy this handle right here, and it has two trigger wires that are embedded inside. If you have that, then that's probably the more a good way to go, because you'll be using the actual trigger of the gun, not putting a wire like this, which is of course doesn't look good, but it works for me. And like I said, I didn't spend. So let's just say I bought this for $50 Canadian, and I bought the wires, and these are floating around my small garage here, so I didn't buy those. So I spent about maybe not even $5. I don't remember. So it's like I said, it's not even $5, something like that, because this is cheap. This wire is cheap, and it's just a few feet. See. So yeah, if you have a good handle, you can buy it in Amazon. It's got a 2 trigger wire. You can see it by looking at the end of the wire. In this case, right there, when you look at it being sold in Amazon, you'll see the ends of this. You'll see this wire, this big wire. You see this hose. Excuse me. You see this shiny. I don't think you'll see it. This this one. You'll see this. So when you see two wires, this one has only one. Like I said, see this right here. See, one wire. Let me just, yeah. One wire hose, the high ampere side of your wire, and this right there, attached to this wire feed thing. So if you see two coming out, then you don't need this anymore. You don't need an extra switch. You don't need this. You just attach that to one positive and one to this, and you're off to the races. That's about it. Simple as that. But yeah, this particular modification is not applicable to all machines. Different machines, different design, but their principle is kind of the same if they have this transformer style. I know right now most of the other stuff has inverter style, so that's a different story. They use MOSFETs and stuff like that. MOSFETs, it's a different design in actuality, so you won't see other transformers like this. They are getting smaller and stuff like that, smaller and powerful. So with our machine like this, it's kind of basic. You can move it around, stuff like that. The only thing electronic would be your motor, your feed motor control. That's about it, and everything else is basically mechanical. So yeah. So that's it. So I hope this video that I made would give you something to to ponder about and make your machine work. And that's about it. I hope you have a good day there. And I don't know where Illinois is. I may be going to look at it on the map. I don't know what time you are. What they call this? Zones, time zones. So I'll be posting this up as soon as I finish this. When I go up the house, I'll just be putting this into Facebook, and so that you could watch. So see you and enjoy and take care, and hope you get yours modified. See ya.